Hi, I thought that I would start doing some live coding from some of the projects that I've been working on to share that so that other people can see what I'm working on. And also, perhaps it'll help me focus the tasks that I'm trying to achieve. And um, maybe I'll get more work done in a more timely fashion. We'll see what happens. I want to share some code from my project. It's a interactive story builder. You may have seen it at my elm-conf talk. Basically, it allows you to build these interactive stories. This is just a very simple demo that doesn't do much of anything. But there's this general layout with some text that authors can create their own stories however they want to. There's some different locations, and we can take a look at home, which is where we are, and you get a nice little text from that. And we have an umbrella, which we can look at or use. And we might want to go over to the garden. We can look there. We can go to the marsh, look around, go back to the garden, and you can see that there's a character here. And we can interact with that character. So all of this is controlled by this simple declarative rule set. And I'll show you an example of that. I have some items, types that I've defined, characters, locations, and for each of those I write some description. And then I have some rules with this little DSL that allows you to change the story. Like in this case, if we interact with Harry, he says, "Meet me in the garden." And we're going to move him or add him to the marsh. So that's where I have a bug currently that I'd like to fix. And I'll show you the bug. So if we interact with Harry, he says, "Meet me in the marsh." And if we go to the marsh, there he is in the marsh. But if we go back to the garden, he's still there. And he shouldn't really be there because a character shouldn't be able to be in two places at once. And when we click on him and we say to add him to the marsh, he should just go there. And that's not what is happening. We would have to add, remove character Harry Marsh. All right, he's currently in the garden. Do that. We play through again. I go to the garden. He's not in the marsh. Go back to the garden. Talk to Harry, and you can see he's gone. And if we go over to the marsh, there he is. And now he's just in the marsh, which is fine. But I don't want authors to have to remember to add and remove their characters every time they want to do something. I just want them to be able to say something like move character, and that should take them out of where they are now and put them wherever we tell them to be moved to. The bigger picture of this is basically we want to enforce a rule that a character can never be in more than one place at a time. So that's the bug that I want to try to solve right now. And I'll show you what we currently have to represent where characters are. I have this characters by location, which is a dictionary of strings, and the values are a list of characters. Now, since this is an engine, I don't know what the characters are. In this case, the characters are my character type, but the engine doesn't know what that's going to be because that's supplied by the author. So C is a stand-in variable for the character type. And the string, when I add a character to a location, I'm just calling toString on the character type, and that's how I'm representing it, which isn't great, but you currently cannot use types in Elm as dictionary keys or in a set because they're not comparable. So until that changes, we have to do something weird like this. So the problem is I'm doing characters by location, and this is not keeping that rule that a character can only be in one location at a time. So I kind of need to invert it. I need to have, instead of a dictionary of each character and what location, or I'm sorry, each, uh, I think I misspoke earlier. The string is actually the string of the location, and each location has a list of characters. And I need to have a dictionary that has the key of a character and which location the character is in. So I did some work on this already to change that, and I have that stashed. I'm just going to pull that back. You can see that I've changed this now, and I will later have to do the same thing for items, but let's just focus on characters for now. So I've changed it to character placements, which is a list of tuples of the character and the location that that character is in. And this isn't a fantastic way of representing this either, because even though just this tuple is a grouping of a character with a location, it would be totally possible to have a list that says Harry's in the garden as the first element and Harry is in the marsh as the second argument. So the structure itself doesn't enforce the rule, and we have to rely on code and tests to enforce the rule. And I actually do that down here. I've also made a move character instead of add character. But you can see that first I remove the character from the list, and then I add it, and that just ensures that I'm never going to duplicate a character. But if I forget to do that, then I could end up in an impossible state, and I have to rely on these tests, specifically this test, that ensures that I'm always in a valid state. And there's a great talk by Richard Feldman from this last ElmConf called Making Impossible States Impossible. And he talks about changing the way you model your problem to make it impossible to be in an invalid state. So I'm currently in an invalid state by choosing to do this list of tuples, and I would like to find a way to make that impossible. And then I won't have to rely on my own code and logic. I won't have to rely on a test to ensure that a character can't be in two places at once. Just to prove that at least it's functional the way it is, I'm going to go back here. So add character has been changed to move character. And in the scene, will also be move character. And now if I go to, again, this is with that code that makes sure that we remove the character and add it with a new location. I can go back to the garden. We see Harry's here. Go to the marsh. He's not here. Go to the garden. Click on Harry, which will trigger that rule, that move. And you can see he's been taken away from there and put back in the marsh. And now that's the only place he is. And no matter how many times I say to move him around, he'll always be in the one place at a time, never in two places. And I'll prove that to start out with. I'll just say move him to the garden, move him to the marsh, and move him to home. So this little bit right here, and you're walking into code that's an existing framework around all this. And if you want to look at all this code, by the way, it is available on GitHub. Not there, here. The Elm narrative engine is what this is. So check it out if you'd like to see the rest of the code of the framework. And if you want to use it to write your own story, you can go to the Elm Interactive Story Starter, which will set you up with what you need to write your own story. But for now, just we'll add code to what I have existing. And the point that I wanted to prove was if I say to move the character in this setup, which is going to do the initial state, I've said this 3 times. Previously with add character, it would have put Harry in all of our locations. If this is working, and these will be processed in order, then Harry should only be at home and nowhere else. So let's go see if that's the case. Here's Harry at home, and he's not in the garden, and he's not in the marsh. So the logic works. Like I said, I want to find a different data structure for this. So what data structures are available that could enforce this rule of my domain? Thinking about it, a sort of map or dictionary seems to be the correct data structure. But again, the problem is I can't put a type as a key. And if I do the toString thing, then I can't get the type back out of the key because there's no inverse of toString. And so if I were to try to do that, let's look at what that would look like. If this were a dict of a string, which would be the character string, and a location, then if I'm trying to get a list of all the characters in a given location, which is something that I need to do, the best I could do is get the string representation of the characters, which isn't good enough. So I would still need to have something like this, which is not going to help us because there's nothing saying that this string is the toString version of this character. And if they were to ever get out of sync, then that would be a problem, and we'd have to just write more tests and more logic to ensure that. So that won't work. What I really want is character, and the value is going to be a location. This is what I want, but this is not possible in Elm. So Richard Feldman also turned me on to this library called everydict, or it's also called alldict. This is just basically the same thing as the dictionary that comes with Elm, except it has a little bit of extra code, which lets you use a type, and what happens is the type gets mapped to something that is comparable under the covers so that you can use it. And the difference between alldict and everydict is with alldict, you provide your own way of mapping a type to something that is comparable. And with everydict, it just uses toString, and you don't have to worry about your own mapping. So everydict will be fine for me. This is an example of how you use it. You give your key, which can be a type, and then whatever your value is, and it will basically make a dict that you can use the same way as you normally would, just a normal Elm dict. And you can use these mapping and folding functions to get the key and do something with it. So that's what I think I'd like to use. I've experimented with it in the Elm REPL. I've made a everydict of this little list right here. So Bob and Jack are my 2 characters, and then I'm just using the string for to represent my location. And then I have this function right here. When I fold, I'm basically pulling out the key and the value and the accumulator. And if the location matches the one that I care about, then I'll stick the associated key to the accumulator. And when that runs, it gives me the correct list of characters, and it is a list of characters. So I can do whatever I need to do with that. So this is basically the function I need for get characters by location. And it looks like it's going to work. So let's go ahead and implement it. I've already added it to my package. So we just have to use it. So instead of this dict, which I think I'm only using, well, we'll keep it for now because like I said, I need to do the same thing with items. So we'll just do every dict. And for now, we'll just expose everything. We might lock that down later. And character placements can be, and you know what, I'm just going to, okay, never mind. Get rid of that one. And in every dict, a character and a location. And that means I'm going to have to change some of my functions. Get characters by location this is that same function that we just looked at in the REPL, basically. So I'm folding with this sort of finding function, which is going to take a character. It's going to go over each key. So this was back when I had a list, which isn't really accurate anymore. So I'm going to change this to key value, and actually we know what these things are, so I'm going to call it character location and the accumulator. And then if the actually don't even need all that, if the location that is pulled out of the as we fold through this dictionary matches the location that has been passed in to our get characters by location function, then we will add that to the end of our accumulator, add the character to it. Otherwise, we just spit out our accumulator. And I think that will work. A few other places that we have to make updates. So move character no longer is dealing with a list, and I no longer need to do this logic to ensure that everything is going to work. I can just probably use one of the methods that every dict gives us. So whenever there's a move character, I basically want to do probably an insert, because an insert, if the character isn't already in this dictionary, it'll put it there for the first time. And if it's not in the dictionary, or sorry, if it is there already, then it'll just replace it, which is the functionality that I want. So I'll rely on that. Insert takes a key and a value and your dictionary. So this will be insert. The key is going to be the character that they give us. The value is going to be the location that they give us, and the the dictionary is going to be state.character placements. I don't need that anymore. I think that should work. And to remove it, we can do something similar. Yep, there's a remove. And if the key's not found, no changes are made, so we don't have to worry about if we give a character that isn't there already. So instead of this, we'll just go with story state, character placements. Sorry, to do every dict.remove, and then character, and pass it in. Right. So I have some errors. What errors do I have? Oh, right. Like I said before, I don't have a character in a location because I don't know what they're going to be. Only the author of the client code knows what it'll be. So we have to represent this with a type variable. So the variable that I need is a C and a B, which you wouldn't know, but my story state has all the type variables, and they are item, location, character, knowledge, rule. So they're given to me in this order of story state, and so they have to line up and match the right type variables everywhere else in this record, and so characters are C and locations are B. So that should fix that problem. And another error down here which says we can't find variable location with this bit. Oh yeah, because I'm sort of shadowing a variable here, so I'm going to just use a little tilde for that. And now we have more errors. This guy says the annotation is wrong. The annotation is wrong. Why? Let's just, I think it's sometimes easier to see the errors in here. So we'll just look here. Oh, actually, there's a problem. Before I do that, I have this code that just initializes my story state. And I was doing, this is the part that represents this character placements array, which no longer is a list. So this should be an everydict dot empty. I'm pretty sure it has that. If I save that, that's good. So then what's the problem with this? They're saying character placements, characters by location. It thinks that I'm using it in the wrong way. Oh yeah, of course. I did not change this to an everydict. Probably saw that while I was typing it. There we go. That should change everything under the covers, and you didn't see me, the part that I popped from get stash was the changes to allow for move character, so that's already in place. So let's see if it works the same way as it did with the list implementation as it does now. So Harry should be in the garden, but not in the marsh. And if we click him, he should disappear from here, go to the marsh, and there he is. That's cool. And just to prove this one, if I do this again and change this to home, change this, actually change this to the kitchen, or there's the kitchen, there's the, he should just be home. There he is at home, and he's nowhere else. Cool, so it looks like we've got the functionality the same as back when it was structured as a list, but because we're using this nice everydict now, it's impossible to have a character that is assigned to more than one location. Pretty happy with that. I have a bunch of tests which aren't even running now because they rely on whatever was going on previously in my list-based implementation. And I think that a lot of these tests can be deleted because they just don't apply at all. Like this test is going to be in the everydict library. When they do their insert, they probably have a test like this, but since they have it covered, I don't need it. I'll get rid of it. And moving a character, I mean, this stuff I could leave it in here just to prove that my move character command actually adds it. This is kind of a really ugly way that I'm testing this, and I think it's because I probably could refactor to improve something. So don't get too hung up on how this test works, but basically I'm just through this, I'm testing sort of the part of the code that takes a list of story commands like the move character and piping the commands through that to get a new state, and that's what these two lines are doing. Basically just adding my test character and then getting all the characters in the current location, which happens to be Earth, and it should give me back just Jack. And I don't know why this is causing a problem? Why is this causing a problem? I cannot find everything. Oh, it is because I did not add this to the package.json. One, no, this one. You have to have all your dependencies in both your level library as well as your testing. So let me just quickly install. This is from, sorry, let's go down to into my tests, and then again, and it will say, do you want to get this new one? And I say yes. And start running. I think it's just what was my task command? I forget how I was running this. I think it was just test. Oh no, that's not how I was running it. I think I have a custom script for running this. Geez, I forget what I was doing to run my test. That's frustrating. What was I doing? I don't remember what I was doing for that. Oh, I think I know what it was. I had this. What I was doing. No, not here. How was I doing this? I don't remember how I was doing this. I'll figure it out later. And oh, this hasn't failed. Well, I'll figure out what went wrong and get back to you later on that. Oh, no. I'll have to get back to you on that. But I assume these tests are just testing that we are adding to the dictionary and removing from the dictionary. The important thing is we don't have to test the part that we've made impossible by using this new structure, and it works over here. So I think that that's a success. I'm going to end it here and come back with some other changes, some other fixes that I want to do, and some changes to the interface, the API and the DSL that I use for telling rules in a future video. Thank you.